everyone. I'm Dr. Li Zhao from the Hong Kong Polytechnic University. My presentation topic is the first real-time measurement method of a wet scrubber on particle purification efficiency with image information entropy analysis. My presentation has 4 parts. The first part is the background. As the data shown, the paint used in China is about 30 million tons per year. About 60 to 50% of them used by industrial painting, such as the car, ship, furniture, and electronic equipment. Nowadays, there are a large number of the workpieces were painted by the mechanical equipment, but there are still a very large number of the large workpieces rely on the manual spraying. So the coating adhesion rate is only about 50 to 60%, which means there are a large amount of pollutant will be released into the working place. So the pollution status in the painting workplace is the mixture of the 3 phases. It has the solid, liquid, and the gas. When the purification system faces this difficult status, the performance of them is lower than 50%. Even more, there are some cases have the negative value. After review, we found the white scrubber with a high prefab effect, which is often used in the painting factories. And this slide is about the literature review of the measuring method comparison of particle removal efficiency of wet scrubber. From the table, we can see the measurement can be divided into 2 tabs. The first tab is the offline measurement method, which is based on the filter paper technology, and the other type is the online measurement, which is use the sensor technology. From the date, we can see there are different. The offline measurement method is often used in a higher upstream concentration than the online measurement, and the offline measurement method often gives us a real value, and which is very time consuming. And this slide is some results about the online measurement method. It is the accuracy decreased with the particle concentration decrease, and it is the interfered by the high humidity and the water droplet. So the both methods are not suitable for the use in the wet scrubber. So there is a lacking of a fast online measurement method of the dust scrubber on the particle purification efficiency. And this part is the method of the imaginary entropy. In the 1958, the Shannon proposed the method to analyze the degree of the complexity of the system, and he used this theory to measure the mean uncertainty and complexity of the system. So in this study, we introduced the information theory into our research and to evaluate the information of the pictures of the wet scrubbers bubble washing. We have established a test system in our lab. As the picture shows, when we running this system, we can turn on the LED light to highlight the work area of the wet scrubber, and then we can use the digital camera to capture the picture of the work area of this wet scrubber. And then we can get a shoot array with the size of the 380 millimeter multiplied 150 millimeter. And then we can get a picture with about 1 million pixels, which we can use in the future analyze for the information. And after we get this picture, we should get the date from this picture. We have 4 steps. The first step is the picture normalization, and then we do the image grading process. That means we make the RGB picture into the grayscale. And the third step is the bubble minimum pixel query window determination. And the last step, we establish the database. And this part is the result. We use this test system to test the particle removal efficiency with the filter paper and make the validation to the method we proposed. When we running this test system, we generate the A2 test dust into the system, and then we use the glass fabric fiber picture to get the sample from the upstream and the downstream of the wet scrubber. And then we use the digital balance to calculate the weight increase and use the equation to calculate the efficiency of the particle removal. And these two picture is the test result. From the picture, we can see the entropy can be used to identify the bubble working status. When the gas liquid rate increase, the operation condition change from the partially bubbling state to a fully bubbly state, and then to over bubbling state. And this picture shows the picture information entropy is correlated with the particle removal efficiency, which means we propose this method is suitable for the online measurement of the purification efficiency of the wet scrubbers. And this picture shows the analysis of the bubble richness besides the picture entropy. From this figure, we can see as the air volume in the wet scrubber increase, the bubbling state over the save plate change from the partially bubbling into the over bubbling state. We can use this state to identify the different working states of the wet scrubber. And then we can divide the working area into 3 parts. That is the bubble generation area, bubble stability area, and the bubble spillage area. After we analyzed the data, we found the average entropy along with the vertical height shows a bimodal distribution. So, and then is the conclusion. For the bubble scrubber, the image information entropy can relax the microscopic property of the gas-liquid flow patterns, and the fast online measurement method is suitable for the wet scrubber purification efficiency, and the measurement error is less than 10%. And we found with the increase of the height between the liquid level and the cell plant, the working area can be divided into 3 parts. And we found the average entropy along with the vertical height shows a bimodal distribution. And then it's a reference used in this presentation. That's all. Thank you for your attention.